Hey, hey, hey. It must be 2 hours UTC because it is yet another daily installation of Astronomy Daily Live coming at you from southeastern Arizona, United States, where the rain has stopped and it's starting to dry out. And but hey, the ground is still like really really spongy. So it's yeah, a different kind of environment for sure. But yeah, we're starting to dry out. So hey everybody, hope everybody's doing well. I've got a kitty here jumping up in the lap. You'll probably see ears popping up. Let's see if I can get him to. Hey there, Bubba. He likes to be in here, I guess, when I'm doing a live stream. So yes, and he's mostly black kitty. He's got a white spot on his chest and a white spot on his tummy, but otherwise he's all black. So yeah, he likes to be here. Whenever he wakes up, he tries to find somebody to say hi to. So hey there, everybody. Um, so this is Astronomy Daily Live. Let me go over here and turn on my Discord audio, which I turned off also. I don't know. What do you think about that? Starting a little bit early and having some kind of astronomical cool picture with a countdown clock. I think I want to get a countdown clock. So when especially new folks come in and they see that it's live, they sort of aren't turned off by the non action. It's always nice to have a clock when whenever. Oh, okay. So I turn that on until I get into a story here. Yeah. Whenever I wrote any kind of program that had sort of a static screen, like control system stuff um, or anything that just had the same sort of looking thing every single time. The one thing that I always put in there was a clock, because if you can see a clock running in your application, then you know that the program is running. Otherwise you don't have a clue. So cool. This is not a programming show. This is an astronomy show. But yeah, I tend to wear many hats, and programming is on my mind today. So don't know why. Don't know why it pops in. Um, so yeah, this is Astronomy Daily Live, and this is a live stream that happens every single day. It's just a casual, fun. Um, Yet I hope the quality is relatively high. Um, don't know if it is. I'm throwing it out there. You're seeing me for the most part. I definitely do not talk this much uh, in sort of normal life. But this is a live stream, and I'm here to talk astronomy. So that is exactly what I aim to do. And consider this like a circle of friends who get together each day and chit chat about various astronomical things. Um, I'd like the discussion to be um, uh, directed by the entire group. I certainly have lots of things that I can talk about, but I don't really consider this a one-man show. This is all about us, and I'm coming together every single day, and talking astronomy, talking science. We can talk computers. A lot of these things are related, right? But I'm definitely going to be skeptical about things. I'm going to look really, really hard at stuff. Um, but I'm also very um, open-minded. So, you know, bring your interesting ideas, bring your interesting news. Um, if you've got questions, as I said, I think there are dumb questions, but it's more in the delivery than anything else. If there's sincerity behind a question, no such thing as dumb at all. If you're just trying to be, uh, uh, mean or trying to push buttons, try to find buttons to push, um, then that's kind of dumb. It's not necessary, and yeah, but any kinds of questions or conversations that are sincere, um, I am all for it. So this is for the newbie, it's for the amateur, it's for the advanced amateur, and it's for the pros. This show is for everyone, and I am trying to invite in um, as many of those as I can, and I will continue to do that too. Hopefully, I don't want to be sort of annoying because that gets, that's just rude, right? So I'm not going, to pummel um, people with, reminders and requests and all that. And when I go on to somebody else's live stream, there's no way in the world that I'm going to say a word unless the host does so first. The host does so first, then I take a little bit of license, to spread the info a little tiny bit. But again, I don't want to take over. I don't want to be rude. They have their show, and if somebody tried doing that here, then it's like, you know, I just want to get rid of them. So, especially if they're a pest, I will definitely promote other shows. And in fact, I wanted to do that right at the top of this. The weekly space hangout is totally awesome. That happens every week. I think it's usually done on Wednesdays. Let me check my notes here. I'm just going to. This is this whole live stream experience is allowing me to learn even more how to use my left hand. Right, I'm normally right-handed, so it's kind of nice um, to do things with my left hand because it's good practice. I've been I think it's absolutely insane for uh, people to sort of uh, be told to choose one hand or the other. It's ridiculous. It's just like you know uh, what we've done in science and engineering um, to half the population. It's like let's just ignore half the population of the planet and see how we get along that way. And it's like right hand, left hand. Let's use them both, right? So I'm I've been practicing using my left hand for many years. Definitely not ambidextrous yet. I do favor the right hand, probably always will. But again, what has that got to do with astronomy? So weekly space hangout for sure. As I said, I think they're going on Wednesdays, if I remember right. Maybe somebody in the chat, Uncle Bill, you can probably tell me when WSH is going on every single week. I think it's Wednesdays. There's also Dennis Hands, big huge shout out to Dennis, still trying to make contact with Dennis. So he's just absolutely not making any kind of response at all. But I'm hoping at some point, maybe he's waiting, to see a little bit of credibility or time put in, or something. Who knows? I don't know. But shout out to him. Check him out on Periscope. He does a Periscope thing, a live thing, every Monday at 8 a.m. Eastern time in the United States, which would be 1300 hours UTC on Mondays. And then he does another Periscope on Wednesdays at 8 p.m. Eastern time, United States, which is 1 hour uh, yeah, which is 1 hour UTC uh, there. So definitely check him out. He's a teacher, and that's sort of how he runs his live stream. He wants to teach people things. He usually just answers questions, and he has a lot of patience. A lot of patience. You can tell he's a teacher. Yeah, he's a good one. Good one. So check him out. His show is, sort of more for the newbie that is coming into this. But yeah, great show. Deep Astronomy with Tony Darnell. He's on. He's on a few times a week, I think. I still haven't nailed all these times down, and that's my bad. My apologies for that. But I know for a fact that he is on live on Thursdays at 3 p.m. Eastern Time, United States. So that's 15 plus 5 is 20. So 20 hours UTC on Thursdays. So check all of them out. Um, yeah, great crowd. Also wanted to give a shout out to Gilles. He does a shortwave live stream at least once a week, usually like on Fridays and or Saturdays. He's awesome. I love his passion. Um, I'm I've I've sort of modeled uh, this show after his. I think I'm sort of, when I think about how I want a live stream to be, it's sort of a combination of Gilles and Rick Beato's live stream that he does almost every single day at 3 hours UTC, which for me, I'm Mountain Standard Time. I'm southeastern Arizona, so I'm 7 hours behind UTC. So when this show starts at 2 hours UTC, my local time, is 7 p.m. So that's nice and convenient for that. Um, so those are the shout outs for now. So as I said, I would really like this live stream circle of friends to uh, be a thing where pretty much anybody can come in and start up a topic and talk about it. That's extremely awesome. But if there isn't any of that, I've got lots and lots of things in my back pocket that I can pull out. So that can include things like question and answer for sure. If you have some um, astronomical questions that you would like an answer to, I can certainly try to give you an answer, or direct you or point you in a direction at least. So hopefully that can be done. But we can talk about um, um, telescopes or um, observing, or various astronomical gear, or cameras, CCDs, CMOS cameras, talk about collecting data and calibrating data. Uh, uh, oh, hey there, Susan. Sunset was good. Yeah, I think I missed it. I completely missed it tonight. Arg. Yeah, the sunsets at my location are probably some of the best I've ever seen, which is another good reason to be where I am. So, yeah, very very cool. What was I talking about? I don't know. Oh yeah, the kinds of topics that we can get into. Data reduction, calibrating uh, data. We can get into different kinds of research. What do astronomers do? Sort of on a daily basis. Do they go into an office? Do they go into an observatory and look through a telescope? You know, what's going on with all of that? I've got a kitty on the floor over here who's playing with he he's playing with something. I don't know what he's after, but he's having fun. I'm glad. I'm glad. Okay, so Uncle Bill is reporting that the weekly space hangout happens every Wednesday at 8 p.m. Eastern Standard Time in the United States. So that's 1 1 a.m. UT time, and I guess Thursday, at least according to what I'm reading on the chat here, uh, um, Uncle Bill, they're also doing it Thursday at 1. Hmm. Right, and then there's the astronomy cast, which is very much like uh, you know, they basically choose a topic, and Pamela Gay talks about it for like half an hour or so. So goes pretty deep. Really interesting, neat stuff. I mean, she knows a shitload, and Fraser is right there too. He's just sort of absorbed this over the years, I think, and so he knows a lot too, for sure. So they're on Fridays at 3 p.m. Eastern, which would be uh, uh, you got to add sorry add 5 to that. So 15 plus 5 is 20 hours UTC, and then also Fridays at 9 p.m. Universal time again. Okay. All right. Well, we'll figure all this out. It's easy enough these days, to search the internet for these kinds of things, and they pop right up anyway. So check all those folks out. This this is Astronomy Daily Live, and it's just a casual get together of friends every single day. We talk about all things astronomical. If there's anything in like the astronomy news that was interesting, we can certainly talk about that. We can pretty much go in at any level that the group decides to go in. So yeah. So tonight's drink of choice is definitely dihydrogen oxide. It's still part of the new batch. Very tasty. Very very tasty. I've got a kitty over here playing with something. Who knows? According to Dennis Hands, the uh, friend on Periscope, he says that um, if if the Earth were flat, if the Earth were flat, then by now all the cats would have knocked everything off. So yeah, the fact that there's still some things, you know, on the planet, that means it's probably not flat. So yeah, he's just succeeded in knocking a few things down already, and he's only been here in here about maybe 5 minutes or so. Pretty wild, pretty wild. Dun, 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 dun. Pinkish sunsets. Yeah, I like it. So yeah, get away from the TV for a while, get away from the news, and join some friends around a circle to talk about, a topic that we're all passionate about. So let's get into it. I was successful in finding the images from the little rover opportunity, and I'm going to share my screen. If you were here right at the beginning of the show, I've sort of haven't decided if I'm going to do this or not yet, but I was sort of thinking that I could start the show with an image like this. Wow, am I completely frozen? I don't know. I'm looking at the live stream over here, and it's like whoa. Anyway, so I sort of thought, if I could throw that up, start this maybe 5 or 10 minutes before the show, but I need like a countdown clock. Yeah, I definitely need a countdown clock. But what this is an image from the surface of Mars that was taken just maybe a day or two ago from the Opportunity rover that is on Mars. So we can go back here. I put in in the link to this data that we're going to be looking at tonight. So this is these are all of the raw images that have come from Opportunity, and as you can see, folks, friends, there are 225,090 raw images that are completely available and free for the grabbing. So hold on one sec. This kitty now wants out of this room. So I'm going to go do that really, really quick. I'll be right back in like 10 seconds. See, for a kitty, it's all we humans are like doormen. We just open we just open doors and close doors for cats. That's our job, and man, we do it really, really well. So here it is. There's almost there's almost 250,000 raw images here, and as you can see, they're coming from various sources, right? These are all the cameras that are on the rover, and there are two cameras that are called the hazard cameras, the HAZ cams. How does the cat get in if the door is closed? The cat is already in here. See, the cat is already in here because he wants to be in here when the live stream starts. And then the live stream starts, and I'm just, I'm going and going and going, and he decides 24 minutes into it that he wants to go out now. So I must comply because I've been extremely well trained. And so I must comply and open the door for him so he can do, so he can go out. So yeah, there are 5 cameras on um, this rover. Uh, Two of them are called HAZ cams, the hazard cameras, and that's exactly what they do. They look toward towards the front of the rover and towards the back of the rover, looking for hazards, right? Things that they definitely don't want to get near or have to go over. or around or anything like that. So they keep a close eye on those guys. There's also a navigation camera, which yeah, I have to remember what all these guys are. So what you can do, you can select any of these. So you can see over here on the left hand side are the various sol days. So yeah, I was reminded today when I was watching the tomorrow um, live stream that it is not pronounced soul, it's pronounced Saul. So uh, the Opportunity rover just passed its 5,000th sol. So that's extraordinary. It has been on the surface of Mars for 5,000 Martian days. 5,000 Martian days. It's absolutely fabulous. So let's just look at these navigation camera images. Maybe we can tell from where they're looking, from where they are looking. That's probably not going to help much. Yeah, these are images of the surface of Mars coming at you almost live. Almost live. It's just a lot of rock. It's a geologist's dream, though, for sure. And if you think about uh, if you think about uh, what this is an image of, it's extraordinary, absolutely extraordinary. So yeah, this is another catalog of sorts that you could literally just spend hours and hours and hours looking at all these raw images from the surface of Mars. It's absolutely fabulous. So there are two other cameras. There is the panoramic camera, which is a big sort of wide field camera, and then there as you can see, there's a microscope as well. So of course, the microscope allows you to see things really up close, seriously up close. So let's just, of course, I picked that one. Okay, this is probably the worst one I could have picked. This series of images was used to create a selfie of the rover. Let's see if we can. I can probably find that pretty quickly and easily. Google.com. Here, Google is our friend. Let's see. We're going to call Opportunity Rover selfie. Here it is. Opportunity rover hits 5,000 and takes a selfie. So as you can see, okay, here's the raw data. Here's all the raw images. Let's look for this one. Okay, let's see if we can find that one. Okay, so you can sort of have a rectangular box here, and then these funny looking things out here. So let's look in this picture and see if we can find that. I don't know if I'm seeing that or not. Huh. Definitely can see the mast, right? Here's the mast. You can definitely see those. Okay. We're trying here. So here's a picture of the PanCam, the panoramic camera, but I'm not seeing that. I think I'm seeing this. You see this 1, 2, 3 dark dots here? 3 dark dots. Ooh, I don't know if I'm seeing that either. Yeah, that's a little tough. It's a little tough. Let's try another one. See this little round thing there? Oh, wow. I don't know if I'm seeing any of those things. Maybe we're not looking at the right data. It's possible. It's possible that we're not looking at exactly the right data. Let's see. Navigation camera. We're looking here, maybe? Let's look here. It is so cool to be looking at Mars, you know? So this is the microscopic imager. So this is looking at things up really, really close. Seriously close. Check it out. That cool or what? We're looking right into some cracks in these rocks. Look at this white line there. Isn't that fantastic? It's just a geologist's dream, right? Dream come true. Look at that. These weird cracks. Really, really weird cracks. Strange looking bright stuff over here. Yeah, who knows? It's all awesome. So I'm, it's all I'm doing when I'm showing you this is just sort of pointing you in a direction, a direction of your own kind of exploration. This data is available, right? It's easily accessible. So go look, go look. You might find something interesting. Who knows? People think that they've seen all kinds of things in these rocks, and you know, it's a it, it's sort of an interesting examination of the human mind and what what we can see if we really want to. But it's sort of like looking at pictures inside of clouds, and our brains want to do that. They want to see recognizable patterns when there probably isn't any. But yeah, we're taking a close look uh, at a Martian rock, and of course these things are everywhere, right? Just absolutely just scattered everywhere. Let's see, that's okay. There we go. But you know, we're trying to figure out what stories are these rocks trying to tell, and I do that. I do that in my driveway, right? I mean, I look down and I see rocks, and it's like, can these rocks tell me anything about where they've been, what they've been through, everything else? And the answer is yes, absolutely. Now, I'm not a geologist, and this isn't a geology uh, live stream, but it is about Mars, and so that is definitely in the uh, in the view of astronomy. So let's see. This goes all the way back, of course, to Sol number one. Sol number one. So let's look at Sol 2 because it says there's 259 images there. So this is just one Martian day after after the rover. This was like back in 1990. I want to say 1997, 1994. I don't remember. Been too long. But let's take a look at a few of these. Oh, I remember these. Yeah, these really cool outcroppings. They sort of landed near or in a crater, if I remember right. And so they were seeing all these exposed rocks, and everybody was just, ecstatic, absolutely ecstatic. All the way back to the first days this rover. The other thing that I put in the in the Discord, I put a couple of other links. One was just a description the of the landing of this rover and its twin called Spirit, which was landed on the other side of the planet, almost on exactly the opposite side. Uh, the cat who walks through walls. You know, I recognize that title, um, Uncle Bill, but I don't remember what the reference is. Is that Heinlein? Is that Heinlein? If you made a reference to Heinlein, then you are definitely a good friend. So this is what happened when these rovers came in. Of course, you know, they flew in on a spacecraft. Um, it is Heinlein. Uncle Bill, I like you even more now. Okay, all right. Hey, Uncle Bill, have you read Grumbles from the Grave? If you haven't, I highly recommend that book. That is sort of a Heinlein autobiography, and it is very interesting. It's very interesting. I'm a Heinlein fan, absolutely. So, yeah, yeah. And anybody who hasn't read Heinlein, definitely grab one of his books. Um, I I don't know which one to recommend as you know as sort of a first read, but I'm sort of leaning towards Starship Troopers. Um, those of you who saw the movie, I'm very sorry that you've seen the movie and have not read the book. I made the mistake of watching some of the movie, and oh my God, what a disaster! What an absolute disaster! Uh, please read the book. So I'm going to recommend Starship Troopers for sort of a first Heinlein read. That's a good intro. Um, it's a little preachy, but that's Heinlein. Heinlein was commenting on the culture of the time, and so he gets pretty preachy. But yeah, I recommend that one for sure. We learned in later novels that Pixel not only walked through walls, but also all the time and space, and even alternate universes. You could always find Maureen. Cool. I'm gonna have to pick that book up. I have never read uh, that particular Heinlein book, so I definitely need to do that. Uh, yeah, cool. Anyway, so back to the Mars rovers. So the spacecraft it came in, made orbit because and and then there were sort of two parts. There's an orbiter, and the orbiter, I believe, was was acting as a radio relay station. Oh, um, um, Uncle Bill, you definitely have to read Grumbles from the Grave. It is an eye opener. It is an eye opener. I'm not going to tell you anything except for the fact that it's like, wow, holy shit, that you really learn some interesting things about Mr. Heinlein in that book. So yeah, so there is one part of the spacecraft that continued to orbit Mars, and another part of the spacecraft that was the lander or um, the rover. So they built this aeroshell, which is this um, really really hard stuff that um, just slows them down, so they aren't going this insane interplanetary speed. Slows them down enough. I think it throws out a parachute at that point. Um, so when they slow down enough, uh, they fire some retro rockets to slow down a little bit more, and then they inflate. They inflate these airbags all around the rover. It looks like a beach ball, but really, really big. I forget exactly how big. I want to say like 20 or 30 feet across. I mean, really, really big. Uh, so these airbags are um, um, inflated, and as you can see in the third point here, right, it says um, after its initial impact, the lander bounces along the Martian surface until it rolls to a stop. I thought that was just absolutely awesome. They tested all this first, to make sure it would work, and damn if it did. And it it not only worked once, it worked twice in in a matter of a few weeks. So and then once it stops bouncing and rolling, they deflate the airbag, and regardless of the configuration, see, they built this thing in the shape of a tetrahedron, which interestingly enough was Buckminster Fuller's favorite shape, favorite solid was a tetrahedron. It's a four-sided object. Each side is a triangle. Uh, so as a tetrahedron, um, they they could figure out what orientation the rover was in when it stopped rolling, and it could um, because it's a tetrahedron, it had the ability to right itself. So uh, so yeah, it just sort of unfolded. I don't remember how it landed, but most likely it landed on its side or upside down, right? So, but because it's a tetrahedron, and they were able, to figure out their orientation um, um, once they were still on the ground. Uh, they could right themselves and then open up, and then the rover just rolled out. It's just absolutely awesome. Deploys its solar arrays, and off it goes. So yeah, very very awesome. I like it. The other thing that I put over on the Discord was just the path that Opportunity has taken. Therefore, well, it's been up there for 5,000 Martian days. But look, I'm gonna. This is the various pieces of the traverse map. So this is a traverse map archive. And let's just go all the way back here. This only goes to 2005. I think that's about right then. Oh, so that only goes back to Sol 481. Only back to Sol 481. Well, let's go back there and see. So okay, well, wow, that's all we've got is just back to Sol like 405, 404, 403, something like that. Wow. So they're not even showing whole the whole map anymore. But we here, at least eventually. Go to the top of the page. All the way to the top. All the way to the top. So this is the latest one. Sol 4997 detailed traverse map, you can see that the images of the ground have gotten better, and that's because of another spacecraft up there called the Mars Reconnaissance Orbiter. Mars Reconnaissance Orbiter, or MRO, has a camera on it called HiRISE. That's HIRISE, which takes these kinds of pictures. And very, very faintly, you can probably not really even see it here, but I can zoom in here a little bit. Wow, that's all we're going to get. Let's go to the high res one. I think there's a higher res one, large. Let's see if this one, this one will do because it's taking 1,000 years to load because I'm taking up all the bandwidth. So we can take a look at this. So here you can, this is the path, rovers. What do rovers do? They rove. So here's Sol 4663, 4664, 4671. So here it is, just rolling along the Martian ground. Isn't that absolutely awesome? What a cool job, to be able to drive around on Mars, because somebody somewhere at a control center, and actually I'm sure this is like a committee, is deciding which way to go, how far to go, how fast to go, when to stop, when to turn around. So look, for the past, um, they they entered their current area, looks like maybe on, I would say, Sol 4718. Okay, well, it's now past Sol 5000. So they've been in this area for like 200 sols, 200 Martian days, just zipping around, going up and getting, not necessarily stuck, but it looks hit a brick wall there, so they're coming back, and then they're doing this and da 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 da. So it looks like right now, just looking at this map, it looks like that's actually where they are. They're up against this thing right here. See, so what you can do, right? You can say, okay, here's 4975. Solve 4975. So now we can go back to the images from the ground. What did I say? 4795? 4975. I'm terribly dyslexic sometimes. 4975. So let's look at the panoramic camera from 4975. So as I just pointed out, right there, it looks like they're sort of up against this ridge or something like that. So let's see if we can see that, if they have any pictures of that ridge uh, available. Doesn't look like it. Doesn't look like it. It's like they're focusing in on very specific places. They're not really doing any wide field, horizon looking stuff. Let's look around a little bit though. So let's go back to 4975 and let's look at like 4976. This is why I say, man, you can just spend hours looking at all these things. Wonder if any of you folks are wondering why they're taking these pictures. So these pictures are for calibration purposes. They are looking, or they're taking all these images through various filters, and so this thing. Let's see if we can find. We probably can. let's see if we can find. Um, I'm going to do another Google search here. Hope everybody's enjoying being on Mars tonight. That's the cool thing, you know. I keep saying this over and over and over again, but one of the cool things about having a daily show is that we can just sort of jump around a little bit and opportunity calibration calibration that anything. Yeah, so here we go. So this is what this looks like on the ground. Why am I not? That's not a great picture. Larger larger view of that. Let's see. Maybe we can find one. Maybe we can find a larger one just so you can really see what's going on. I guess all of these. Oh, here we go. Here we go. Let's see if we can find a largish one. That's pretty big. That one. Well, that's not great either, but it does the job. It's sort of, it gives you an idea, right, of, I don't know. But you can see that, it's showing grayscales, it's showing red and green and blue and sort of this orangey color. It's got this, it's got that dot and that dot. So we can go back to the raw data so you can sort of see. So this, I don't know what the orientation is, but these would be the colored ones, right? And then you can see the different scales of gray and blue. This thing is probably a thing to give uh, an idea of where the sun is in the sky, because we know how high this is. We know how high this is, so we can measure the length of the shadow, and we can sort of line up the top of this with the top of this and say, the sun is obviously over to the right and a little bit behind this thing. So it gives an orientation, uh, and it gives color information. So that's really, really important stuff. I don't know what this is over here. I don't know. Is there no? I don't know if is the writing on there. Can we see? Oh, and this one we can't. I don't. Oh, yeah, yeah, yeah. We can. Look right down here. There's some kind of writing there. You see, we got this dark line, this dark line, this dark line. So let's go back over here. Oh, I see. See, these are other grayscale type things, but it says two worlds, one sun. Let's see. Two worlds, one sun? Yeah. Oh, that's so cool. That's so very cool. Anyway, so those are the calibration images. I was hoping that we could find sort of some pictures of that ridge, 4975. So let's look at 4967. We can go back to oh, I think I got rid of that one. Oh well. So 4967. Let's see if there's any pictures of the ridge. No, there's not going to be any. Pictures of an interesting rock. Yeah. Oh well. Anyway, you can spend hours and hours and hours. I'm glad I found this. Um, so the Spirit rover has the same kind of thing. In fact, we could probably, yeah. So all raw images. Let's see, panoramas. There's all kinds of cool stuff here. Yeah, you can also look look at these images in 3D. If you've got, the 3D glasses with the red on one side and the blue on the other, you can actually look at these images in 3D as well. So this is just it's just let's see, let's just download a large one here. You can just get an idea, right? So they take a picture in blue and a picture in red, and then they combine them, and so yeah, you're able to see things sort of in 3D as well. Let's look at the Spirit raw images. I think, yeah. See, they stopped. It looks like they sort of stopped taking data from this guy, so they must have turned Spirit off. Spirit got stuck a little while ago, and I think they sort of ended the mission there on opportunity instead. Wow, what is that? Okay, it's just a hole. Okay. Interesting stuff though, huh? Pretty cool. Yeah, Mars is absolutely fantastic. And to be able to see things on the ground from you know southeastern Arizona, USA is very cool. All right, well, cool. Let's see. I did want to remind you that there's a possibility possibility that I will not be doing a live stream tomorrow. Um, there's a I would say at this point there's a 99.5% chance that there will be a live stream, but there's a very slight chance that I'm just not going to be here. So so yeah, just a warning about that. Warning about that. Let's since we're doing Mars, let's just do it. Let's go over to high rise and take a look at some pictures from above. That'll round out the hour. And as I said, I'm sort of doing this just to sort of show off some interesting things that I enjoy. Uh, this this definitely isn't diving into the science or anything, but it's really awesome to have a daily show because I can do this and not really worry about trying to pack in as much information as possible and having to speak really fast to do all that, and just take our time and enjoy the view. One of the things that I really enjoy about the high rise images are the brief descriptions, the titles, I guess, at this point. So uh, aeolian source layers exposed in western, um, I don't even know how to pronounce that, Abalos scopuli. It's a place, man. It's a place on Mars. So that's just a little thumbnail. What I like to do is I like to come down here to JPEG and go to non-map, because then you get the full high res image. And what I like to do is I like to, I have it load, but then you can zoom in and then just sort of scan it. Looks like a coastline almost. But look at all these weird things, weird looking things. I'm thinking that this is sort of the high ground, and then there's a slope going down, and then this is sort of the low area down here. And we're seeing all these weird, bright features. Hmm. Mars is a very mysterious place. Got all these sand dunes over here. Look at those. Yeah. That's not the most interesting thing I've ever seen on Mars, but it's pretty interesting anyway. Look at these weird rings. And this cutoff here, it's just baffling to me, absolutely baffling. So that's not incredibly interesting, although the title is very, very cool. Let's just see. And these came down on the 7th of February, so just a few days ago. Terrain sample west of um, Panchaya region. So let's see. I do exactly the same thing. I just go to the JPEG non-map, black and white. Not necessarily interested in color, not interested in projecting onto a surface or anything like that. Just give me the nice raw flat data. So look at this. This is the surface of Mars. Let's go back and see what the pixel resolution is really quick. Gives the pixel resolution. See, it gives that when all well when this image was taken on the 1st of January at 3:28 Mars time, local Mars time, at a certain latitude and longitude, how far away it was. So every pixel on here is 124.2 centimeters. So that's about 1.24 meters per pixel. So okay, that gives us sort of a scale, an interesting scale. So then we can load this guy and say, okay, these are pretty big things. Look at all these, look at all these boulders. These are on, the pixel scale. So we're talking about 1 to 2 to 3 meter diameter boulders. Look at that. See these dark things? Look at these dark things. I guess they're explaining those as paths of like dust devils. So there are, and these dust devils have been observed on Mars, and apparently, at least the theory says goes that these are paths that the dust devils take, and they stir up the ground underneath them to expose you know a little bit of the lower so-called darker layers. They go in lines and they twist around and looks like a spider web. There's a little crater here, maybe 20 meters across, 30 meters across. So this is the size of a pretty big house, right? That crater right there. So you can see that these paths are really wide. These paths are maybe 10 meters wide or so, and some of them even wider. Just very, very cool. And look at the texture. Isn't that a weird texture? I wonder what that's like to be walking on that. I mean, we humans wouldn't really even show up as one pixel on this. So this is not really a human scale. It's getting close, but it looks really, really bumpy. Really bumpy. Here's a weird looking black thing down there, on also the size of a small house. Look at all these little boulders, all these little outcroppings of boulders here. Hmm. That's it. Oh yeah, we're still going here. If I go all the way down on one side, wow, look at all these boulders. Wow. Wow. Yeah, just amazing. Mars is absolutely fabulous, isn't it? Look at that. Got this outer thing, and then the crater itself. And there's more boulders, lots of boulders here. So then I go over to the other side, and I go up the other side. We'll just shoot through this. More craters, more dark dark lines, whatever those are. Lots and lots of boulders. This is a boulder field. If you were walking around this, it would just be just boulders everywhere. Big rocks. Very cool. Never get enough of this. All right, let's look at one more, and then I think I'm going to call it a good evening. This looks pretty interesting. Terrain sample in Neochis region. That looks kind of interesting. Thumbnails sometimes are very appealing as well. So let's see. Sometimes it's a disappointment. So this is a big image, taking a million years to download. But we can start. See how much that zooms in? Fabulous. You know what I always forget to do, and I went too far, is I want to get the pixel scale. I want to know how big a pixel is. So now we're talking half meter pixels, half meter pixels. So this is really high resolution here. Let's see what interesting things are here. Lots of boulders. Do you see? I don't know if you can see this or not, but these boulders are casting these long shadows. Long shadows. So that means that the sun is at a very, it's very, very low on the horizon. It's either, early morning or late afternoon on Mars. These things are casting these hugely long shadows. You see that? But it's really, really cool because, if you look at these shadows, and this is, these are really, really small, so it's hard to see. But if you look at the shape of the shadow, you can get a sense of the shape of the rock, right? And look at this one. It's got this really, really bright top to it and this really long shadow. So this is like a pillar, right? It's sort of like a pillar. Wow, that's amazing. So again, it's just this boulder field. Look at these. Wow. Look at these cool shapes of the shadows. That's awesome. It's really, really rocky. It's I mean, imagine walking around in these things. These are wide enough to walk through. Every pixel is half a meter. So this little, sort of canyon here is a good, oh, it's got to be a good, 5 meters across. So, you can you could drive a car through that, no problem. So I like to imagine, walking around on this stuff. Probably getting some dark stuff. This is mostly just shadow. That's why it's looking so dark. Yeah, this is a very, very low solar angle. Very low solar angle. Okay, we're going to move over here and scan up. There's a lot going on in this area. Look at this. Look at this line of, ugh, who knows? Who knows what's happened here? Nobody knows. Look at all those holes and rocks. Nobody knows. That's too much. That's too complicated. Look at this. Look at this weird groove. It looks like an L. It looks like the letter L. Or maybe it's got a thing here. See? So, as I was saying before, our human brains, you know, look for patterns. It's like, wow, that almost looks like a structure. Probably not. Skeptical and open-minded. That's my mo, and that is definitely what this live stream and this channel is all about. Is you know being completely wide open to what are we looking at here, but also being extremely skeptical about any. any certainty. What an amazing place, you know? It's about as amazing as Earth. Yeah, very cool. All right. Well, I think I'm going to stop sharing. I'm going to come back here. And yeah, you didn't get a chance to see this shaven face here, but here we are, and it is 3:10 UTC. So we've gone for a good hour and 10 minutes or so. Hope you enjoyed that. Um, yeah, we humans love to explore, and it is so cool. It is so cool to be able to send, these probes, these really, really, really tough probes out that can be our eyes and ears and noses and skin and taste buds and all of that to put all of our human senses into different places in the universe. It's absolutely fantastic, and it is very, very cool. To be living in a time where we can um, you know see places that you know at least from here is just a point of light in the sky, but it's a real place. It's a real place. And yeah, we're trying to figure out if we can actually live there. Um, go there ourselves, set up camp, set up more than a camp, set up cities, set up a civilization. Um, a lot of people have, some really, really awesome, awesome plans, to do that. And man, I am all for it, all the way. We definitely need to uh, get ourselves off of this planet. Uh, there is so much out there. It is unlimited. It's unlimited, and if we can realize that, that will change us forever. We're not going to have to we're not going to have to worry so much about the things that we worry about now. Think that there isn't enough, and we have to fight for everything. And if we don't fight for things, somebody else is going to take it. Well, when you get it in your head that there's there's enough there, we can have anything that we want as much as we possibly can. That's going to change how we think. We're not going to worry about that anymore. So we can do cool stuff instead of fighting over ridiculous things. Uh, Not necessary. Not necessary. Yeah, it's we are so lucky, Susan. To be living now, where all this thing can come to us in the comfort of our own home, right? The uh, um, the images that I was just showing from high rise was actually uh, that camera was built built and tested at the University of Arizona in Tucson, and yeah, and that's where they continue to operate that camera. It's from a little building off campus, and you would I don't think you would ever know what that building is for. If you drove by it, I'm sure it's got a label on the front, but yeah, you never know. Otherwise, what the amazing things that are going on in that building. Those folks are having meetings about talking about what they're going to look at next, um, what they've looked at before. They have all the computers and everything to hold all these images for us, and and um, yeah, it's just absolutely amazing. It's absolutely amazing. All right, I am going to get out of here. See, NASA recently posted a Curiosity um, video of it looking back and down the mountain slope. Yeah, yeah, yeah. Very cool. I'm gonna have to look for that one. Um, Curiosity is having some trouble with its wheels. So, man, we've got a nuclear powered rover on Mars that could literally be running for 50 years, 100 years, right? But those wheels are not going to make it. Those wheels are not going to make it. So, damn, that really, really sucks. So at some point, they're going to have a failure, and it's going to have to stop roving. But yeah, it's amazing, um, the planned uh, 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 science mission of the Opportunity rover um, and Spirit was 90 days, 90 Martian days. And Opportunity has just passed day 5,000. So hats off to the engineers who built that thing. It's unreal. It's unreal that it is still going. It's solar powered. It's solar powered. So, and they were worried for a while because um, both of the rovers they accumulated dust on their solar panels, and so they were observing that every single day they were getting a little less power, little less, little less, little less, little less, because of the accumulation of dust on the solar panels. And so they were making projections in terms of when when they were going to um, start to use more power than what they actually collected per day, say. Uh, but then something extraordinary happened. Something extraordinary happened that I don't think no one ever thought. No one ever thought. But uh, a windstorm, a windstorm came along and blew, really hard. There's not a lot of atmosphere on Mars, so you can get away with 200, um, 200 or 300 mile an hour windstorms. But what that did, the windstorm blew most of the dust off of the solar panels. So they regained almost all their power. And so, these windstorms, they happen, from time to time. I don't know if they're seasonal. I don't know if there's any kind of correlation there at all. I think they might be seasonal, but um, uh, uh, the wind blows the dust off of the panels, and so they're okay. They're okay. So that's really, really, that's the only reason why Opportunity continues to this day, is because of Martian weather. Martian weather saved Opportunity. So it's very, very awesome. Yeah. Um, yeah. Cleaning events. Yeah. It's awesome. It's absolutely awesome. Now, Uncle Bill's saying that most of the wheel damage happened early. Um, okay. All right. Cool. Yeah. Hats off to not only the mechanical engineers and the electrical engineers, but also don't forget the software engineers. Um, if it wasn't for software engineering, spacecraft like Voyager um, probably wouldn't have been um, running now either. So yeah. I mean, it definitely takes. In this case, it takes a team of really, really, really smart people, like mind-blowingly smart. Um, they and I just hope, I just hope that all or most of the people are having a great time, that they're having the time of their life, are having great fun. Um, I am definitely having fun just looking at the results of their work. It's awesome. It's absolutely awesome. And to be a part of that, and to be the one that is writing the code to do things, or you know building that calibration structure, and doing um, the engraving, uh, and knowing that that is there. It's there right now, um, doing its thing, sending data back, and producing these awesome pictures. All right, I get really excited about um, these kinds of things. So and it's partially due to the dihydrogen oxide. It's very energetic. So cheers. And I am going to exit these waters for now. Um, I've got to get back up. Sorry, duty calls. So yeah, um, there is a 99.5% chance that I will definitely see you tomorrow. There's a very slight chance that maybe not. Very unlikely. So very unlikely. So most likely I will see you in 22 hours and 39 minutes. So have a great evening and a great day. And yeah, I will see you tomorrow. Peace out.